Okay, everybody, this is Mr. Ainsworth, and we're going to get into a full quadratic review. I'm talking about how to solve quadratics using all the different methods, how to graph quadratics of all the different types. So get the following things ready. Get your red pen out. All right, make sure you do that so you can annotate well. Get your pencil, of course. All right, and also your TI 84 graphing calculator that you use to check your quadratic functions and check your vertices and check your graph. Okay, so let's use them all. All right, here we go. Grab your pencil and let's get started. We're going to talk about the different methods how to solve quadratics first. All right. Okay, the very first thing we learn how to do is solve a quadratic by factoring. Okay, whenever you see two terms here that have a common factor, you always factor out the GCF. That is the first basic technique. You got to factor out the GCF, man. Okay, and guess what? Between 4 and 20, the GCF is 4. If you look and compare x squared to x, well, they have an x in common, right? So they have a 4x in common, so you want to factor it out. All right. Now, when you factor out the GCF of 4x, what you're doing is you're dividing it out. So 4x squared divided by 4x is x, and then 20x divided by 4x, well, guess what? That's 5, right? And so you have, when you factor out the GCF, which is 4x here, you divide it out, and whatever is remaining goes inside the binomial. You check by distributing back through, okay? So 4x times x is 4x squared, and 4x times 5, well, guess what? That's 20x. You check by distribution. So distributing out can be checked by distributing back through. Step 2, all right, you want to set each factor equal to 0 and solve the quadratic, just like we did on the left. Okay, all these examples on the left will help you on the right. So here we go. We're going to take 4x equal to 0, and we're going to take x plus 5, set that equal to 0, and we're going to solve. Okay, divide by 4, and you get x equals 0. That should make sense. 4 times 0 is 0. Negative 5 plus 5 equals 0, so we should get negative 5 here, and which we do. Okay, we have two solutions. So x equals 0 and negative 5. Two solutions max for these quadratics, okay? Sometimes you have two solutions, sometimes you only have one, sometimes you have none, depending on what's going on. All right, but the maximum you can have is 2. So let's solve by factoring again, okay? This is, again, a factoring technique. This is our first technique when we solve quadratics. In this case, we have a trinomial here. And whenever you have trinomials, you got to kick in a step, and you got to set it equal to 0. So get your red pen out, and let's subtract 5. And let's see here. What do we get? We have 6x squared minus 13x minus 5 equals 0. All right, and now we're going to factor by grouping. And when we do, we multiply the first and third terms. So we go 6 times negative 5, all right, is negative 30. So what two numbers multiply to negative 30? All right, and add to this middle term negative 13. Well, I know that 2 times 15 is 30, so I'm going to write down 2 and 15. One of them has to be negative. So 2 times negative 15 is negative 30, and 2 plus negative 15 is negative 13. So there we go. So I'm going to split the middle term, all right, and do some factor by grouping. This is the main technique I taught my class. All right, it is not always used by all instructors. There's like many different techniques to factor a quadratic, so if you don't like this technique, you can use your own. All right, but we're going to split the middle term here, and we get 6x squared plus 2x minus 15x, because that's negative, right? Minus 5 equals 0. So I split that middle term. Notice that negative 13x is the same thing as 2x minus 15x. So I just rewrote it, okay? I rewrote it, basically. Let me speak correctly here. So now we do some factor by grouping. All right, we've got to factor out the GCF just like I did in problem number 1. So we factor out the 2x, divide them both by 2x, and we get 3x plus 1. Check by distributing back through, right? 2x times 3x is 6x squared. 2x times 1 is 2x. Now here they're both negative, and they're both divisible by 5. So I'm going to factor out the negative 5. And I get here, I get 3x plus 1 again. Negative 5 times 3x is negative 15x, and negative 5 times 1 is negative 5. So notice right here, the 3x plus 1, well, that's in common, right? So you factor it out. So 3x plus 1 times the remaining factors, 2x minus 5, and that goes here. So 2x minus 5, and that's equal to 0. Okay, so now you do the same thing we did up here. Set each factor equal to 0. So 3x plus 1 equals 0, and 2x minus 5 is equal to 0 as well, because we got to kick in the zero product rule, right? Something times something equals 0. This is called the zero product rule. You can look at your notes and look at section 6.5. All right, when we did the factor by grouping, solving quadratics by factoring, we kicked in the zero product rule. When two things multiply to 0, one of them has to be 0. So you set them both equal to 0 and solve for the values that make them equal to 0. So let's solve the first one. We get negative 1/3. Solve the second one, and we get 2x equals 5. Divide by 2, and we get x equals 5/2. So my two results here are negative 1/3 and 5/2, or 2.5. Once again, you have two solutions. All right, next technique is solving by square roots. So let's do that, okay? And then basically we want to isolate the square. All right, look at this. Major step, isolate the square. So what we want to do is isolate this x squared, and we're going to do that by adding 48 first. So what do we get? We get 6x squared equals 48. Divide by 6. You get x squared equals 8. All right, step 2, square root both sides. Notice step 2 right here. Square root both sides. Okay, root here, and put the plus or minus symbol in. All right, the square root cancels out the square, giving you x, and that's equal to plus or minus square root of 8. That's equal to plus or minus root 4 times root 2, and that's equal to plus or minus 2 root 2. Okay, once again, two solutions. This means 2 root 2. It also means negative 2 rad 2. All right, two solutions here. All right, now, if you're using this as an instructional video, keep in mind that this is a video, right? And you can pause, play, rewind. Okay, so if I'm going too fast, or if you need to listen to it again, rewind it. Okay, just don't copy and take notes, because you're not going to understand it and you're not going to get any better. Pause, rewind it, and then go back and listen to it again 2, 3, 4 times until you understand it. Okay, even I do that as an instructor when I'm learning new concepts that are higher than this. Okay, so it's okay to do that. So go at your own speed, pause, play, rewind, do what you need to do. All right, next one. Same thing, we're going to isolate the binomial, just so we did it on the left. So we're going to isolate this binomial here, and we're going to do that by adding 12 first. Always add the opposite first. So you get x plus 1 squared equals 12. Step 2, square root both sides, just like we did over here on the left. So we're going to square root the left side, and we're going to square root the right side too. And when you do that, put in your plus or minus symbol, because you're going to have two solutions here. The square root cancels out the square, giving you x plus 1. When you get plus or minus root 4 times root 3, you always simplify the root. Okay, split the root is what I say in my class. Okay, split the root. Okay, that means simplify it. 4 times 3 is 12, right? So root 4 times root 3 is root 12. And so you get x plus 1 equals plus or minus 2 rad 3. And the only thing you have to do is subtract 1. And you get x is equal to negative 1 plus or minus 2 rad 3. And you can't go any further than this, because you can't add or subtract before you multiply. All right, 2 root 3 is 2 times root 3. So you're not allowed to combine this in any other way. So you're done. So the two answers are negative 1 plus 2 root 3, and the other one, negative 1 minus 2 rad 3. Two results, as I keep on saying here, when you're solving these quadratic functions. Okay, next, completing the square. All right, so what you want to do first is check the quadratic here and make sure that the lead coefficient is 1, okay? The lead coefficient must be 1, and it is not, okay? The lead coefficient right here is 3. So like we did on the left-hand side, what we're going to have to do is divide everything by 3. And I'm talking everything. All terms by 3. And I get x squared. Now see, now it's 1x squared, or x squared. Now the lead coefficient is 1, plus 2x plus, minus 3 equals 0. 0 divided by 3 is 0. And now we do the completing the square game. So here we go. We're going to get the constant on the right hand side. That's step 2. I'm going to add the opposite. Put that in red here. And what we're going to do is we're going to leave room to complete the square. So we have x squared plus 2x plus something equals 3 plus something, okay? Now when you complete the square, it's always b divided by 2 squared. That's the completing the square process. So here, b is 2. I'm going to highlight the middle coefficient. It's right here. Just like on this case, I took 6. 6 divided by 2 is 3. 3 squared is 9. I added 9 to both sides. And I'm talking about here and here. That's when I complete the square. Over here, I take 2. 2 divided by 2 is 1. And 1 squared is 1. So I need to add 1 to both sides. So it's that simple, believe it or not. Okay? I always do the little side work over here. So over here, let's see here. Now we gotta simplify and play the factor game. So here we go. What two numbers multiply to 1 and add to 2? What two numbers multiply to 1 and add to 2? Well, there's 1 and 1, right? 1 times 1 is 1, and 1 plus 1 is 2. So we want to split the middle term. Okay, notice that x plus x is 2x. I just split the middle term. Right side's 4. I do some factor by grouping. Notice that I just gave this binomial, the last two terms, the third and fourth terms, a hug. I just put parentheses around it and I put a 1 in the front. So you can see that the common factor is the x plus 1. And then we factor that out. So notice that the common factor right here is x plus 1. I factored it out and I multiply it by the remaining factors x plus 1. And remember that in this technique, they'll always be the same. That's why we use it, because we're going to rewrite it as x plus 1 to the second power equals 4. At this point, we square root both sides just like we did up here in the previous problem. So we learned from experience, right? Okay, so we're going to square root both sides. Put the plus or minus symbol in, and then the square cancels out the square root, or the square root cancels out the square, excuse me. I get x plus 1 equals plus or minus 2. I subtract 1. I get x equals negative 1 plus or minus 2. And that means two things. It means negative 1 plus 2, which is 1. And it means negative 1 minus 2, which is negative 3. So I have two answers, 1 and negative 3. All right. Okay. Next, we have the quadratic formula. Now, this is just one of these deals where you have to memorize it, okay, and to be able to apply it. Okay, so memorize it. It's negative b, or opposite of b, plus or minus the square root of b squared minus 4ac, 4 times a times c, divided by 2 times a. So the very first thing that you need to do is set this baby equal to 0. Always set it equal to 0 first. Okay, this one's set equal to 0, so we're good. So a, b, c. So a is 1 here, lead coefficient. B is negative 3. Always real numbers, okay, not variables. C is negative 5. And then you go for it, okay? So x is equal to the opposite of negative b, which is, the opposite of b, which is negative 3, plus or minus the square root of negative 3 squared minus 4 times a, which is 1, times c, which is negative 5, all divided by 2 times a, which is 1. And then you simplify it. Just use your arithmetic. I see double negative here, so I get 3 here, plus or minus the square root of 9. Negative 3 squared is 9. I see another double negative here, and 4 times 1 times 5 is 20. So I get plus 20 here, divided by 2. So my end result is 3 plus or minus the square root of 29, divided by 2. And because this right here, this is a prime number, okay, it cannot be simplified. So root 29 cannot be simplified. All right, why? Because it's prime. So you have two results, 3 plus root 29 divided by 2, 3 minus root 29 divided by 2. Okay, once again, two solutions. All right, and now let's get into graphing quadratics. All right, let's do a full review on that too as well. Remember, this is a video, so if I go too fast, you can always pause it, rewind it, and listen to anything you want. Okay, so we're going to go back to basics. We're going to take something in factored form, and we're going to express it in standard form and find the vertex first. Okay, so I'm going to rewrite it here. So y equals x plus 3 times x minus 1. We're going to multiply here using FOIL. So y is equal to, all right, we got x times x, which is x squared. We have x times negative 1, which is negative x. And then we have 3 times x, which is 3x. And then we have 3 times negative 1, which is negative 3. And then we simplify. So we have y is equal to x squared. Negative x plus 3x is positive 2x minus 3. From that point, a is 1, b is 2, and c is negative 3. So a is 1, b is 2, c is negative 3, and we can find the axis symmetry. Okay, so let's do that first. So x is equal to negative b over 2a. So negative b divided by 2 times a. So x is equal to negative 2 over 2, or negative 1. At this point, when we find y, the y coordinate of the vertex here, you got to take this and you're going to substitute it back into the original function. All right, you got to substitute in. So y is equal to negative 1 plus 3 times negative 1 minus 1. You got to substitute it everywhere you see x right here. Or you can use the standard form of the equation too as well. You're going to get the same value, right? Because they're the same functions, just different forms. This is standard form and that's factored form. Okay, so let me see. 2 times negative 2, that's 4. Excuse me, negative 4. And so my vertex v is negative 1 comma negative 4. All right, now since a is 1, all right, the lead coefficient right here, a is 1, this tells me that the parabola opens up. Okay, it looks like this, all right, which means I have a min. Okay, so let's graph that first. Let's graph the vertex. So left one down 4. We'll put v there, so negative 1 comma negative 4. And let's draw the line of symmetry. Always plot your vertex and the line of symmetry first. All right, plot first. I tell my students that. And then draw your line of symmetry. And your line of symmetry, the axis symmetry, line of symmetry right here is x equals negative 1 because it passes through negative 1 on the x-axis. Okay. Now, what we want to do is we need some points and we're going to reflect them. So always pick a couple points to the right of the vertex, like 0, 1, and 2. All right. So always pick a few points to the right of the vertex. So pick x values right of the vertex. Okay. Now once again, let's go back up to the vertex. The vertex is at negative 1, negative 4, right? Well, the x value, look at the x-axis right here. To the right is 0, 1, and 2. So I'm going to use those values. So here we go. So 0, 1, and 2. Let's substitute them in. So y is equal to 0 plus 3 times 0 minus 1. That's 3 times negative 1, or negative 3. And the second one, when x is 1, so we have 1 plus 3 times 1 minus 1. That's 4 times 0. That's 0. And the last one, when x is 2, we have 2 plus 3 times 2 minus 1. 5 times 1, that's 5. All right, so let's plot. We're going to plot and reflect. Okay, plot and reflect. Everybody say plot and reflect. Okay, okay. All right, so we're going to plot and reflect. So 0, negative 3. So 0, negative 3 is right here. And since it's 1 unit away, we reflect it right over here. The next point is 1, 0, which is right here. And we should know that it's right 1 up 1 and the right 2 up 4. So we expect that. It's 2 units away, so go 2 units on the other side. That's called reflecting. All right, plot and reflect. And last one, okay, 2, 5. So we're going to go up here to 2, 5 and reflect. It's 3 units away. So go 3 units away on the other side. All right, and then graph your quadratic. Okay, draw a smooth curve. There we go. All right, now parabolas go infinitely up, so continue it up. Okay, and notice that this is a minimum. All right, this is the minimum y value. All right, and it's equal to -4, and it's a minimum. I can see graphically from the from looking at where the x-intercept or x-axis hits the parabola that we have an x-intercept at -3 and 1. So -3, 0, and the other one at 1, 0. Just by looking right here, okay, and right here. Those are called x-intercepts. This one's at 1, 0. This one's at -3, 0. Okay, now it's easy to determine the x-intercepts on the graph because you just figure out where it crosses the x-axis, right? So it's where the parabola meets the x-axis, okay? It's easy to identify that. However, if you don't have the graph, how are you going to find the x-intercepts? Well, you do that, all right, by setting y equals 0. Because notice that the y coordinates are always 0 on the x-axis, right? So we're going to set y equal to 0 and we're going to solve for x. So I'm going to put a 0 right here, okay, where I see y. 0 equals this. So 0 equals x plus 3 times x minus 1. So you just take your function and set it equal to 0 and solve for x. That's all you do. And guess what? It's already in factored form. So you set each factor equal to 0. All right, and solve. So here we go. So you go x plus 3 equals 0, x minus 1 equals 0. So you solve them independently. And notice you get -3 and 1, which is what we expected because look at the x-intercepts, -3, 0 and 1, 0, right? They intersect at -3 and +1. All right, and so these x-intercepts here are the same, okay? These right here are the same as above. And so same as on the graph. So you can compare and you better get the same values. That's how you know you're doing it correctly, okay? And last and final step, the domain. The domain for all parabolas that open up or down is a set of all reals, okay? That's the symbol for it, or you can say all reals. And since the vertex is a minimum, and it was at, let's look at the graph again here, -1, -4, all the y values on the graph have to be greater than or equal to -4, because guess what? That's the minimum y value, because they lie above it, and they're greater than. So because the y minimum here is -4, look right here, the range, which is a set of y values, as opposed to the domain, which is a set of x values, is always greater than or equal to this minimum, which is -4. So remember, this depends on the vertex. Okay, I'm talking about the range. Depends on the vertex. Let's highlight that. Okay, now remember, this is a video, right? So if you're not used to this, you can always rewind this and listen to it again, okay? Because this is obviously a big lesson here. So take advantage of the technology and do that. Now the next parabola is not in factored form, it's in standard form. So let's take a look at how we handle that. Basically, it's the same as what we just did before, conceptually. All right, but we start off with a different form, and since it's in standard form, we can determine A is 1 here, B is -2, and C is 3 automatically. So you write down your values. All right, you write down your values for A, B, and C, and then you use them down here, just like we did before in the previous example. So let's find the axis symmetry and the x-coordinate first. We got negative b over 2a, so negative of -2 divided by 2 times a. That's 2 divided by 2, so x equals 1. Then we take this and we substitute it back in. All right, so y is equal to 1 squared minus 2 times 1 plus 3. So 1 squared minus 2 times 1 plus 3. So you get 1 minus 2 plus 3. And let me see, that's -1 plus 3 or 2. So the vertex is 1, 2. Now, I'm going to check that right now. So I'm going to kick in a little technology. Check this out. So we hit y equals and enter your function, this function right here. So enter in x squared, all right, minus 2x plus 3. And we're going to go zoom 6. And we're going to see the parabola, which I haven't graphed yet, but we're going to see it. And I want to determine if this point right here, hit trace, is actually, or the vertex is actually 1, 2. So I'm going to enter in 1 and hit enter. And look at 1, 2 at the bottom of the screen. The question is that really the lowest point? Is that actually the vertex? So we're going to go second trace or calculate. Notice the calculate menu comes up. I hit the second button first because it's in blue and it's all color coordinated. So you got to go second calc to access the calculate menu. It's a minimum because it opened up, so I want to hit number 3. And then left bound means you go left to the vertex and select enter. You'll see it right there. And then right bound means goes right of the vertex. And then select enter, and then it says guess, well, put me back at your vertex, which is in the middle. Hit enter again, and you'll see, you see 1, 2. 1.00000. Okay, 2 is the same thing as 1. Just round it. So 1, 2. And notice that I verified my vertex using the technology. All right, piece of cake. I'll be right back. Okay, so now we plot that vertex and draw the line of symmetry. So we're going to go right one up 2. And we're going to draw the line of symmetry immediately because this helps us reflect every point. Always plot the vertex and draw the line of symmetry, or what's called the axis symmetry. In this case, it's at x equals 1 because it passes through 1 on the x-axis. And this is at 1, 2. Now, since a is 1, a equals 1 tells me that it opens up. All right, looks like this, something like this right here, and it tells me also that I have a minimum. So this is the min y value. So right away I already know that even before I graph the parabola. All right, now I need a few points, okay? I know if you know the vertex form, which you guys do, you can go from this point, you can go right 1, up 1, right 2, up 4, and then plot and reflect and graph this function. You could do that. You could also get points to the right of the vertex like 2, 3, and 4, 2, 3, and 4, and get them this way as well, and it can verify it. Like I can already tell you that it's going to be right here. We're going to go right 1, up 1, and then reflect, and then right 2, up 4, 1, 2, 3, 4, and then reflect. I can already tell you that these points are going to be on the parabola, but I'll prove it to you. Let me derive them down here. Okay, so let's substitute these in. So let me see, 2 squared minus 2 times 2 plus 3. That's 4 minus 4 plus 3, so that's obviously 3. And then 3 squared minus 2 times 3 plus 3. I'm just substituting in where I see x here, and that's 9 minus 6 plus 3. 9 minus 6 is 3, plus 3 more is 6. And then 4 squared minus 2 times 4 plus 3. That's 16 minus 8 plus 3. That's 8 plus 3, or 11. So 2, 3. Let's see if that's on the graph. Oh my gosh, it is. Okay, isn't that amazing? Okay, so everything that I've been telling you is true, guys. 3, 6, is that on there? Let's see here. Right 3 up 6. There's 3, 6 right there. I already plotted it. So we're going to plot and reflect, and then you draw your graph. Okay, you draw your parabola, as it is called. and they're smooth U-shaped curves. Smooth U-shaped curves. All right, no V's. Do not connect the points. All right, they're smooth U-shaped curves. As I said over here, look at this. See that right there? It's a smooth U-shaped curve. No corners, no edges, no straight lines, okay? Okay. And notice that this does not pass through the x-axis, right? So there are no x-intercepts, okay? None, okay? Does not, parabola does not cross the x-axis. That's the reason why. So parabola does not, I emphasize not, cross or meet, okay, x-axis. That's why there are none. So you can't write them, you can't find them. In fact, even if you did try to find them by setting y equals 0, you're going to end up with an issue. So let's try it just for funsies here. We're going to substitute y in 0 in for y. Okay, right here. 0 equals x squared minus 2x plus 3. And you could try to factor this, but this is not factorable. All right, I don't know of two numbers that multiply to 3 and add a negative 2. Can't do it, so it's not factorable. So you're going to have to use a quadratic formula. So A, B, and C. So A is 1, B is negative 2, C is positive 3. So here we go. So the opposite of B, so negative and negative 2, plus or minus B squared, negative 2 squared, minus 4 times A times C, all divided by 2 times A. And if you try to solve this, there's a double negative here that you can simplify, so you get 2 here. All right, plus or minus, look at this, 4, negative 2 squared is 4, minus 12 divided by 2. And guess what? 4 minus 12 is negative 8. And so what you'll end up with is 2 plus or minus the square root of negative 8 divided by 2. And this part right here, this is not real. Okay, not a real number. And I'm going to prove that to you too, so check this out. Get your TID4 out, go second mode, quit out, get to your home screen, and take the square root. Okay, let me clear this out. So go second x squared for the square root, enter in negative 8, and press go. Look at this, non-real answer. Okay, it's not real. As you're going to find out in Algebra 2, it's actually imaginary. And so what this tells you is that there's no x-intercepts. That's what it tells you, no x-intercepts. The domain is still all reals, okay, for all these parabolas here. And the range, though, depends on the vertex. So let me see, we have a parabola that opens up, it has a minimum. So this right here is the min y value. And it's equal to 2. Whoa, what happened there? And the min y value is equal to 2. So that means all these y values above it have to be greater than or equal to 2. So your range, which is a set of y values, is dependent upon the vertex, and it has to be greater than the minimum y value. Remember, the vertex, in this case, which was a min, was 1, 2. And so therefore the range is greater than or equal to 2. All right, there we go. That's this one here. There's a few more, but I'm going to pause. I'll get back to you. Now remember, this is a video, right? So you can always rewind this and listen to it as much as you want. All right, make yourself proud. And I'll see you in my next example here in a momento while I take a little break. All right, let's get to vertex form now, guys. This is the cool part because you don't even need a table of values. The only thing you need to do is know what the parent function is. All right, so the first one here is y equals the quantity of x plus 4 squared minus 1, where in this case, we need to know a. A right here is your lead coefficient, and I can see that a right here is 1. So since a is 1, our parent function, okay, right here is y equals x squared. So we're going to go right 1, up 1 from the vertex, right 2, up 4 from the vertex, right 3, up 9 from the vertex. So we use the parent values right here to graph this translated or shifted function. Now this right here, x plus 4, since, let me say x plus 4 can be rewritten as x minus a negative 4. That's the same thing as x plus 4. Notice that if you compare the two, h has to be negative 4, and this minus 1 here, well, that's your k value. So I can see h here, and I can see k here. So h is not positive 4, it's negative 4, because remember, it's always x minus something equals this. All right, and then your plus or minus value on the outside, your k value, that's your vertical shift. Okay, so in this case, your vertex v is -4, -1. So I plot the vertex first. Okay, it opens, A is 1. Oh, I forgot to mention this. Parabola opens up, okay? Opens up because A is 1, it's positive. If it was negative, I'd say it opened down, okay? But A is positive, so it opens up. It looks like this somehow, okay? So let's plot the vertex first, which is left 4, down 1. So left 4, down 1, which is right here. -4, -1. Plot that axis symmetry like you always do. And now use your parent values. We're going to go right 1, up 1, and reflect from the vertex. So put your pencil at the vertex and go right 1, up 1, and then reflect. And then go right 2, 1, 2, up 4, 1, 2, 3, 4, and reflect. 2 units to the right, 2 units to the left. Reflect, reflect. And then go right 3, 1, 2, 3, up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 3 units away, so go 3 units on the other side. Okay? Reflect, and then you graph your parabola. Okay, parabola is continually going up forever. So smooth U-shaped curve. Smooth U-shaped curve. And then you fill out the other important information, like the domain is always a set of reals for these parabolas that open up and down, because you can it doesn't matter, x can be negative, positive, 0, it can be any real number. Range depends on the vertex. This is a minimum, okay? This is your min y value right here. The min y value is equal to -1. That's the lowest point. Lowest point on the curve. All right. And because of that, all the y values that are above it have to be greater than or equal to -1. So y greater than or equal to -1. And your axis symmetry right here, okay, it passes through -4 on the x-axis. So x equals -4. Well, that's all there is to it. All right, so let's get some experience. Now here, the a value right here is -1. So there's a right there. A is -1. Because of that, it opens down. All right, and because of that, we have something that looks like this right here, and we have a max. Okay, so far I know that. Then here's h and here's k. It's x minus h, so h is 2, not -2, but 2. And then k is 4, because we're adding 4, not subtracting 4. And this is a max. So we're going to plot 2, 4. And then we're going to use the parent values. Okay, so instead of going right 1, up 1, I'm going to go right 1, down 1. Instead of going right 2, up 4, I'm going to go down 4. Instead of right 3, up 9, I'm going to go down 9. Okay, so from here, put your pencil at the vertex and go right 1, down 1. Okay, and then left 1, down 1, or you can reflect it. And then right 2, down 4, and then left 2, down 4. Or you can reflect, and then right 3, down 9, just way down here, and then reflect. Or you can go left 3, down 9, and then, of course, you got to draw this curve. Okay, now the x-intercepts are here. There is one and there is one right here. 0, 0, and 4, 0. So 0, 0, 4, 0. Domain, all reals. Range, now this is a max. This is the max y value. Max y value in this case is equal to 4. That means all the y values on the curve, since they're below it, have to be less than or equal to it. So y less than or equal to 4. And axis symmetry right here, and it passes through 2 on the x-axis, is x equals 2. Okay? That's how it is done. Okay, that's how the game is played. All right, you just need to get used to it. Okay, on this one here, so here on this one, a is 1, so it opens up. Okay, and we have a min. So we have a min here. at -4, -1, so -4 comma -1. And let's see, so we plot that, -4, -1. Oh, you know, I forgot to change this. I'm going to change, this is the same thing as we did last time. So let me see here. Yeah, okay, I'm going to change this here. So I think what we did in class, I think this was 5. Okay, so I'm going to change this to 5. So it's going to be -5 comma -1. So I'm going to fix this, okay? Got to change it. Same thing, A is 1, so it still opens up. So we're going to go left 5 up 1. I mean down 1. So there's your vertex, -5 comma -1. And we're going to draw the line of symmetry here. Okay, and then from there you go right 1 up 1 and reflect. Right 2 up 4. 1, 2, 3, 4. Reflect. Again, 2 units on the other side. And then right 3 up 9. Parent value, okay? So this right here is very important. This tells me that it behaves and it has the same shape as your parent function y equals x squared, which has the parent values 0, 0, 1, 1, 2, 4, 3, 9. Okay, this is the parent. Okay, and then I go right 3 up 9. So right 3 up 1, 2, 3, 4, 5, 6, 7, 8, 9. And then reflect over here, 3 units on the other side. Okay. Okay. Domain all reals. Range y greater than or equal to this this minimum here, -1. Axis symmetry, x equals -5. Okay, now this one, what did I change it to? I think I changed it to I totally forgot. So let's see here. I'm going to change this to, nope, change it to 1 here. I'm going to change this one to 1. So on this one here, A is -1, so it opens down. Okay, there's A right there. A is -1. Vertex is at 1, 4, so 1 comma 4. If it opens down, it looks like this, and it has a min. So there's my minimum y value right there. So 1 comma 4 right here. And then draw your axis symmetry immediately because it helps you plot and reflect. And then you go right 1 down 1 because we're going down. Okay, right? And then reflect it, or left 1 down 1, right 2 down 4, and then left 2 down 4, right 3 down 9, and then left 3 down 9. Okay, and then you draw your curve. Okay, no, it's that simple, guys. You just have to get used to it, that's all. Okay, and in this case, we have these two x-intercepts right here. Okay, we have one at -1, so -1 comma 0, and then we have 3 comma 0. Range, or excuse me, domain, all reals, and this is a max. Why did I say min? Sorry, guys. This is a max. It's a high point, right? So I didn't mean to confuse you guys there. All right, and so that's a max y value, so the range y less than or equal to 4. Okay, this is the max y value right there. And the axis symmetry is right here. All right, it passes through 1 on the x-axis, so x equals 1. All right, only 2 more to go. All right, in this case, A is 2, so it's positive. Vertex is -5 comma -1 by looking at it, so I can look here and here. Now, because it's positive, okay, I know it opens up, okay, which means I have a minimum. Looks like this. All right, and in which case it has a minimum or a low point. Now, because A is 2, all right, it tells me that my parent function is 2x squared. So instead of going right 1 up 1, I go right 1 up 2. And then instead of going right 2 up 4, I go right 2 up 2 times as high, or at 8. Or then instead of going right 3 up 9 for the x squared function, I go 2 times 9, or up 18 high. So, which I may not be able to graph. So we have to plot first, left 5 down 1. There's your vertex. Draw the line of symmetry at -5, -1. And let's see here. Okay, so I go right 1 up 2 now. So we're going to go right 1 up 2 from the vertex, and then reflect, and then right 2 up 8, right 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, and then reflect. Okay, notice this is more narrow now because A makes, when the value is 2, it becomes more narrow, as you guys found out in your earlier lessons. Okay. All right, so it's more narrow because A is 2. You got to go up twice as high. So this affects the shape. So right here it makes it more narrow. Okay, the domain is still all reals, range. Since this is a minimum, this is a min y value, and it's equal to -1. So y is greater than or equal to -1. And the axis symmetry right here, it passes through -5. So it's x equals -5. Now when a is -2, it opens down instead of up. All right, so let's do the last one here, and this will finish our review. So here, the vertex is 3, 8, h here, k here, so 3, 8. A is -2, so it opens down. So it looks like this, and it has a max. Okay, so this is a max vertex because it has a high point. So on this one here, on your parent function, if we were to plot just a couple values here, if you substitute 0 in here, you get 0. 1, you get -2 times 1 squared, which is -2, and then -2 times 2 squared be -2 times 4, or -8. So in this case, we're going to go right 1 down 2, right 2 down 8. These are your parent values. All right, so here we go. We're going to plot the vertex first at 3, 8, and draw the line of symmetry. All right, and then we're going to go from that, we're going to go right 1 down 2, and then reflect. And then right 2 down 8, which is right here, and then left 2 down 8, which is over here, or you can just reflect it. So remember, I always say plot and reflect. Okay, and then you draw your curve, your parabola. Smooth U-shaped curve. It gets wider as it goes lower. Whoa. There we go. All right, now we have 2 X-intercepts here. We have one here and one here. So 1 and 5, so 1, 0, 5, 0. Those are the X-intercepts, domain, all reals, range. This is a max y value. All right, equals 8. So y is less than or equal to 8. And the axis of symmetry is right here, and it goes through 3 on the x-axis. So x equals 3. All right. And I think that finalizes the review. So this is a video, right? So you can always go back to the beginning and learn some more, review it. Okay? This is Mr. Ainsworth. I'll see you in my next lesson. I'm tired. I'm going to go to bed. I'll see you then. Bye-bye.